How will SpaceX manage to have the same system for Starship and Super Heavy no matter from where they launch? How will they unite land and sea-based launches? And how will the orbital launch sound suppression system work? Let's find out.
What about it? Go for launch.
We're go for launch. Looks like it's handled.
Ignition sequence start.
My name is Felix and I am your host for today's episode of What About It? And as always, there's been a lot going on in the space industry lately, so let's dive right in.
Starship updates!
I am back from the most epic community meetup in the history of the channel, and it's my daughter's 7th birthday today, so this one will be slightly shorter than usual. That doesn't mean though that there's less to talk about when it comes to SpaceX and the Starship. Quite the opposite, actually. SpaceX is not standing still. Never, ever. Progress is made day and night, and the Starship construction and launch site in South Texas, also known as Starbase, does not pause for a second right now. What you're looking at here is segment number 6 of the currently constructed Starship Launch Support Tower. It's been moved from the Sanchez site, by now a part of the construction site, towards the launch site a bit further down the road. LabPadre's cam of course recorded the whole scene for all of us to see. Thank you, Lewis and team, you rock. Of course, Lewis wasn't the only one either. Brady Kennison from NASA Spaceflight recorded as well, and you can really see how routinely the SpaceX workforce is handling these extremely large tower segments. Every other day another one is added to the tower right now. The Launch Support Tower will play an essential role in the upcoming orbital Starship and Super Heavy flights, and the timeline Elon Musk has set for this project is extremely short for such an undertaking. Never in the history of humankind has such a large launch site been built so fast. Truly inspiring to watch, and the focus of the entire spaceflight community for a reason. SpaceX is shifting boundaries and setting new records and limits on almost everything they do here. And SpaceX already brought the LabPadre LR11350 in position for the next stacking. It seems like my estimate from 2 episodes ago might come true. A few more weeks and SpaceX will only be busy applying last details to the construction before first ground personnel trainings can commence. And of course, SpaceX is already getting ready for the next lifting of segment number 6. Up until recording this episode, it didn't happen yet, but don't be surprised if it's already up by the time you're watching this. SpaceX's progress can be measured by the days that go by. Every day something new is happening. So now that we know how SpaceX is getting the launch support tower up so fast, we'd like to know what's going to be the workhorse of the tower, right? How is SpaceX planning to stack their Starships and Super Heavy boosters with it? Let me introduce you to the NOV Rig Technologies ADS-30Q. A drawworks AC motor system normally used on oil rigs to lower and lift entire drill strings into and out of drill holes. 6,000 horsepower, weight 74 metric tons, a maximum of 16 lines and a maximum hook load of 1,245 tons. Here you can see a 3,000 horsepower setup running. The spinning center drum is attached to powerful AC motors and large disc brakes on the sides. A steel cable is either wound up or unwound from it. The cable runs up inside the tower to a so-called crown block with large pulleys inside. And the system has already been installed at the base of the tower, exactly in the same way it would be installed on an oil rig. This way the force can be redirected anywhere it's needed. In theory, this could either power the stacking crane or the catching mechanism to slow down a booster softly and even without the need of counterweights. This also gives SpaceX one huge advantage. The system they are testing here with the land-based orbital launch support tower will already be in place on the sea launch platforms. SpaceX is likely going for this system to be able to install the same kind of design on all the offshore platforms they intend to use in the future. Brilliant idea again. The best part is no part, and the second best part is the one already existing and ready for integration into the own design. Even for a drawworks, the ADS-30Q is large. In NOV Rig Technologies lineup, it's the king, and nothing comes close to its 4 AC motors totaling a crazy 6,000 horsepower of combined force. Again, SpaceX is setting the bar higher and higher with everything they're doing in Boca Chica. The orbital test phase will provide us with pictures never seen before. But all the transports, starships, tower segments, GSE tanks, countless trucks, deliveries, cars, all has to go through a tiny bottleneck.
It's out in the nowhere. Oh, that was a little left. It's all good.
When I went to visit Boca Chica in March 2020 before COVID made it impossible to travel from Europe, I drove on Highway 4 and let me tell you, it wasn't a pleasant ride at all. It was a small road leading towards the beach that hadn't seen any love for years, as it wasn't used that much either. Fast forward 14 months of trucks and SpaceX straining Highway 4 to the limit, the road was even worse. Now the small road has reached its limit and SpaceX has finally decided to show it some love. Major road construction is being done right now to ensure that the first Super Heavy booster will have a smoother ride than the suborbital Starships that flew before it. And in the middle of all this construction going on, SpaceX even manages to test prototypes. This is NASA spaceflight and the second BN 2.1 testing. BN 2.1, for those who do not know, is a small test tank simulating a full Super Heavy booster engine section and an oxygen tank. SpaceX is validating the design on this small test tank to make sure everything is as it should be for the real deal. The full-grown BN2, which right now is being built in the high bay. The tank passed a few cycles of cryogenic nitrogen fueling and detanking in short succession. No pop, no visible problem. Everything seems to have gone as planned. While the cryogenic nitrogen is being pumped into the tank, and while BN 2.1 is being pressurized, hydraulic rams under the tank press up with immense force to simulate thrust from the Raptor engines that will fire while the real deal is launching for the first time. Progress, progress, progress. Next up, we're going to take another close look at some yellow mystery pipes and the latest knowledge about the SpaceX orbital launch pad sound suppression system. Here we go again, the Windows 95 screensaver being built by SpaceX at the launch site right now. It's growing larger and larger. SpaceX workers have been busy connecting more and more pipes into something no one can really make a sense out of at this time. Those are pipes normally used to run natural gas or maybe even water through them. Looking at it again from RGV's perspective, it shows though that these kinds of angles really don't make much sense if you want to run fluid through it. For those use cases, you use round bends to minimize friction and to maximize flow rate. Some of the bends are beyond 90 degrees and very pointy. Sifting through your comments from the last episode showed me that you're as clueless as I am. There are all sorts of ideas and we're all thinking together right now. Let's get some facts straight. Because of the sharp and pointy bends, I am ruling out a fluid system of any kind right now. Judging by the size and the strong walls of these pipes made out of solid metal, the end result will be a pretty strong construction. The angles show that some sort of force needs to be distributed throughout the pipe frame. The construction will also be pretty large. It seems that SpaceX is building two triangular frames. Lots of pipes are still not used. Will they be connecting the two frames? If so, it kind of looks like a huge stand or maybe a part of a rack. I've heard the idea a few times that this might be a pathfinder for a catching system. The only official design description we've ever gotten so far was this tweet from Elon Musk himself. The Starship launch tower that catches the giant rocket booster is basically Mechazilla, just needs some legs. What? I don't know if these triangles fit that description, but I'll definitely keep you in the loop as more information emerges. Next, let's take a look at Orbis' masterpiece so far. Of course, some of it is still speculation, but SpaceX 3D creation Eccentric has made a stunning animation showing all the different components of the orbital launch mount as they might operate, and I'll talk you through. Cybertruck for scale. We're starting with a little modification that's likely to come for the orbital launch mount pillars. These curved steel girders have been spotted on site, and I do find Ovis speculation that they are a part of the OLM very fitting. Next, we have a part that's currently thought to maybe be a transportation jig. I do agree with Ove on this one as well. It does look much more like a part that will be used more often and for a different purpose. Could this be a part of the sound suppression system that will definitely be needed for Super Heavy? Now we add the clamps that have already been manufactured and are being integrated into the launch table. I do think that those will form a table ring on the inside on which the booster can sit. And here comes the inner ring of the already existing launch table. 11 meters diameter, so wider than the booster or a Starship. You can easily see how the hydraulic arms reach through the construction to be able to move freely. They will retract once the booster is lifted off so that an absolute minimum of wear and tear is reached during a launch. If you want to do 3 launches per day, there is no time for maintenance on the launch mount. Launch, check, launch in quick succession. These are the launch table intersections. Purpose: make it as rugged and durable as possible. Thick steel plates are welded in place already that will be extremely durable. A pipe circles around the launch table to feed the water system. Solid steel plates are added below the hydraulic arms, 20 centimeters thick, anchor points, mounting points for the inner ring on which the booster will sit. They can take a lot of weight. More steel beams are added to reinforce the structure even further. Solid square tubes above each lower mounting point of unknown purpose are being routed through the intersections. Those might either be used for a different fluid system or work as cable protections. Now let's add the internal structure work. Reinforcements everywhere, double wall facing the inside of the launch mount. Nothing is supposed to get through here. There are 20 narrow and 10 wider sections on the table. They are being closed off with thick steel plates on the outside that on their own have a hole to be able to still access the complex inside of the launch table. Finally, we add the thick upper and lower rings of steel that finish the construction, actually turning it into the launch table we've already seen. All in all, a complex and unique design, but what is all the complexity for? For just a few seconds of violence created by 32 Raptor engines. Water shoots out, engines ignite, the inner ring retracts, and the booster is on its way. The idea right now is that the sound suppression system will shoot a large amount of water into the inner ring of the launch table, creating a vortex as it falls down and is being vaporized by the engine exhausts at the same time. It's a technique used by other launch providers as well. The water has excellent dampening properties as it dissipates a lot of heat and noise while turning into vapor. Huge thanks go out to Ove from SpaceX creation Eccentric for providing us with this animation. Ove, you rock! Of course, some of this is still speculation, but I think we're getting very close now to the real deal. Absolutely stunning to see the whole system work even before it's built. Links to Ove's YouTube channel and to his Twitter can be found in the description. Show him some love too, he deserves it. Today's supporter shoutout goes to Mono, Kim Rüggen, Orhan, Ertugrul, Alberto Fori, Alex Seve, and many others. You rock! Thank you so much for all your support, and make sure to join us on our supporter exclusive Discord so that I can thank you in person. Today's team shoutout goes to all those who made the trip to Mechanisch and were part of the most epic thing to ever happen regarding the channel. This meetup was just amazing, incredibly interesting, and a huge amount of fun. 60 plus people, hype trains, Tesla roadsters, giveaways, countless interesting discussions, and a huge bunch of space nerds connecting, meeting, and talking. On top of all that, the chance for me and my wife to finally be able to give something back to you. People thanked me for doing this. I want to turn that around and thank you for making all this possible in the first place. You all rock so much. Have a great day wherever you are now, and we're already looking forward to doing something similar in the US next. These curved steel gerber. It seems like my estimate from 2 seconds ago. So now that we know how SpaceX, judging by the size and SpaceX already brought the LabPadre, the fuel grown, I'm sorry. Okay. How do you grow a super heavy booster with fuel?